Most surprising is Mercury, the least explored of the rocky planets, because of the difficulty of getting into orbit around a planet so close to the Sun. 5, 4, 3, main engine start 2, 1 and 0, and liftoff of Messenger on NASA's mission to Mercury, a planetary enigma in our inner solar system. Now going through the sound barrier, following a direct route to Mercury would be impractical. A spacecraft would arrive at such high velocity it would need to haul a prohibitive amount of heavy fuel in order to slow down enough. We just had spacecraft separation. Brownwood solids have jettisoned, so Messenger controls its speed by stepping from one planet to the next, using their gravity to slow itself. Even so, Messenger still approaches Mercury moving so fast that it is forced to fly past the planet 3 times, slowing on each pass, until, after nearly 7 years of flawless navigation, it arrives safely in orbit, at last able to begin its mission mapping Mercury's surface. That first image ever acquired from orbit around Mercury was amazing. When it finally came in, it looked perfect. It looked exactly like we expected it to be. For me, that was the real moment when I realized that we had successfully made it into orbit and everything was working. This pioneering voyage has led to a completely new idea of how Mercury may have formed. Mercury is the most cratered planet in the solar system, with many puzzling features that hinted at a violent past. Mercury has a very unusual orbit. If you were on the surface of the planet, you would actually have to go around the Sun twice to get one full Mercury solar day. Also highly unusual is the planet's disproportionately large core. Mercury is basically a big ball of metal surrounded by a tiny bit of rock. How do you end up with a planet that has so much metal inside, and then almost none on its surface? That was a huge mystery, and the major question is why? Why is it like this when the rest of the planets aren't? A clue to understanding these strange features was found in Mercury's chemistry. So very soon after we got into orbit, we started to get chemical data back from the surface, and we immediately got some surprises. The tiny probe detects volatile chemical elements in concentrations that no one had thought possible this close to the Sun. These are elements that go into rocks, but that evaporate at relatively low temperatures. And it immediately told us that some of the older ideas of how Mercury formed could not be correct. What Messenger discovered about Mercury could suggest a new twist in the story of the solar system. Just a few million years after its formation, the young Mercury is seething with the heat of its violent birth. Slowly, a crust forms, rich with volatile elements. If it had been close to the Sun, these elements would have evaporated before the rock hardened. So, what could explain why they're so abundant on Mercury today? The orbits of the planets and their current locations have changed over the history of the solar system, so where things are today doesn't mean that's necessarily where they formed. They could have, and probably did, move from different locations to where they are now. One possible thing is that Mercury didn't form where it is today. If it were much closer to the other planets, maybe even outside of Venus or Earth, or somewhere in between there. If Mercury had formed near Earth and remained at a more comfortable distance from the Sun, its destiny could have been very different. But it wasn't to be. So what turned it into the strange sun-scorched world we see today? We don't know the full story. What we have right now are theories, and as we gather new observations, we're trying to change everything to fit those observations. Messenger's evidence of the volatiles on Mercury's surface and the unusual size of its core suggest an interesting new theory. It's possible Mercury began life as much as 160 million kilometers further from the Sun than it is today. In the region of space where the young Earth is also forming, a region with scores of planetary embryos all fighting for position. In the chaos, it's possible that something large pushes Mercury off orbit and in towards the Sun. Mercury brushes against another planetary embryo, this glancing blow removing much of its crust and mantle. Now, little more than a metallic planetary core, Mercury continues toward the Sun, ending up in the peculiar elliptical orbit we see today. Before we sent the Messenger mission to Mercury, I think we had a very simplistic idea of what it was going to be like. And Mercury turns out to be a more complex place with a more interesting and complex history than we had previously imagined. But of course, all things have to come to an end, and once we were out of fuel, we could no longer burn our engines to keep from crashing into Mercury. After 4 years of observations, Messenger's mission came to an end. The spacecraft adds yet another crater to this tiny world, where any prospects for life were scorched away when it was thrown too close to the Sun.